Hey guys, my name is Nonthakrit and today I'll be talking about Ohm's law. So now, what is Ohm's law? So Ohm's law is a law stating that electric current is proportional to voltage and inversely proportional to resistance. The person who discovered this law is George Ohm. Now, how did he discover it? Ohm's main interest was current electricity. He did a magnitude of experiments so he could have extremely accurate details in his work. In 1827, he was finally able to show from his experiments that there was a simple relationship between resistance, current, and voltage. Because the law was initially only a theory, a lot of people ridiculed him for that and didn't really give him credit. A year later, Ohm finally got credit and recognition for his discovery from the law. The next thing we talk about is how this law is used in everyday life. So now I'll be showing you 6 examples and explaining how each of them use Ohm's law. The first example is a conventional fan. We can control the speed of fans at our homes by moving the regulator. The current flowing through the fan is controlled by regulating the resistance through the regulator, and then a circular knob on the component can be rotated to achieve a variable resistance on the output terminals. For any specific value of the input, we can calculate the resistance, current, and power flowing through using Ohm's law. The second thing is electric heaters. Now, electric heaters are common appliances used during winter throughout the world, and the heaters will have a metal coil which has high resistance and permits a certain amount of current to flow through, and that will provide a specific amount of heat. The power supply to the heaters is calculated using Ohm's law. The third thing are kettles and irons. Now, the electric kettle and an iron have a lot of resistors in them. The resistors limit the amount of current to flow through them to provide the required amount of heat. The size of resistors used in them is determined by using Ohm's law. The fourth thing we'll talk about are the designs of electronic devices. Electronic devices such as laptops and mobile phones require a DC power supply with a specific current, and many of these devices need a certain amount of current and voltage to operate. Ohm's law tells us the amount of resistance we need to establish a certain current with a certain amount of voltage. The fifth thing are fuses. Fuses are the protection components that limit the amount of current flowing through the circuit and to establish a certain amount of voltage. They are connected in the series in the device, and Ohm's law is used to figure out which resistors are needed in the fuse. The last thing are chargers. So mobile and laptop chargers also use DC power supplies in their operations. The DC power supply provides a variable output voltage based on the resistance and the overall working, and is also controlled by Ohm's law. Now I'll be using the Ohm's law formula to do a couple questions so you can understand how to use the formula correctly. So for the first question is asking what voltage will produce a 0.35 amp current through a 750 ohm resistor. So though the first thing you should do is write the formula, which is V equals to I times R, and then after that all you have to do is just put in the numbers that you get from the question, and then you will be able to get the answer. Now the second question is asking a hair dryer draws 6.5 amps when it is plugged into a 120 volt outlet. The first thing you should find is what is the resistance of the hair dryer, and then how much charge passes through it in 5 minutes. The first thing you should do is write the formula V equals to I times R. But since we are looking for resistance, you change the formula to R equals to V over I. Then the next step is just to put in the numbers you get from the question to get the resistance, which is 18.5. Now for the B part, you use the formula I equals to delta Q over delta T, and then you change that to delta Q equals to I times delta T. Then you use the things that are also given in the question, and then you get the time just from doing normal math, and then the answer you should get is 1950 C.